So before we can identify our point to be a maximum or minimum, let's revise. First, we have to find out our critical point. So once we get our critical point, we can do first derivative test or second derivative test so that we can identify it is maximum or minimum. So for first derivative test, normally the first derivative test is discuss about the gradient of the tangent to the curve. So let's say this is your curve. So at this point, the tangent will be like this. So this gradient will having positive. So at this point, this is will be tangent. So this tangent you can see is going downward. So this tangent is negative. So relative extrema only occur at stationary point where f prime x equals to 0. The first derivative equals to 0. So this is where we start our critical point. So when we start our critical point, we get our x coordinate and y coordinate. So our point maybe can be maximum, maybe can be minimum. So those points we can call it turning point also, or we can call it stationary point also. So not all the stationary point can be extremum. So sometimes you can get inflection point, maybe. So we have to undergo our test. So after we get critical point xy, the first derivative test is about the gradient of the tangent. So you can see the gradient of the tangent. So for critical point, for stationary point, you can see the gradient of the tangent at this point, there will be 0. So you can see the gradient here is 0. So when we're doing our first derivative test using table, we have to analyze our point before our point and after our point. So we have to analyze by interval. So the interval before our point and the interval after our point, if it has a gradient positive change to gradient negative, so very obvious, we can conclude that this point is maximum point. In other case, if this one is our point, if our gradient of the tangent, the value change from negative to positive, means our point here, critical point, will be our minimum point. And sometimes we can notice that this is our critical point. And before the critical point interval, we notice that the gradient of the tangent, our first derivative test, is negative. After the point, also negative. So this point may be a inflection point. So to be confirmed whether it is an inflection point, we can do our concavity test. So go back to this first derivative test, which is the gradient of the tangent. We look at the gradient of the tangent. So if we have our gradient of the tangent before that, before the C interval is positive, after the critical point also positive. So this kind of situation, they will give us an inflection point situation. So for the first derivative, we can identify and we can justify our point whether it's maximum or minimum, or we can justify our point, is it an inflection point. So continue. So what is inflection point? Inflection point, actually you can see the curve is changed from concave downward and then to concave outward. So this is called inflection point. So this is called maximum point. If your point fall at here, this is your maximum point. If your point fall at here, this is your minimum point. Or in other case, the inflection point can be defined as this is concave outward and this is concave downward. So let us observe second derivative test. Back to our critical point just now. Besides using first derivative test, observe the tangent to identify its maximum or minimum or inflection point, we can use second derivative test. So second derivative test, for here we are doing calculation. So we use our critical point that we found just now, the xy. or to be more accurate, if our critical x is equal to c, so our coordinate y will be fc. So we substitute the point. We substitute the point into our second derivative test. We do calculation. If we can get the result less than 0, means this result give you a concave deviation downward. So second derivative test is a test about concave deviation. So this is concave outward, this is concave downward. So when you substitute the critical point into second derivative, you get negative, means it concave downward. So obviously you can justify your answer, your point is a maximum point. If you substitute a critical point into your second derivative and then you notice that it is positive, positive means it will be concave upwards. So when you notice that you have concave upward, means the point that you substitute there is a minimum point. But if you substitute into your second derivative test, you get 0. So when you get 0, we cannot conclude that that is maximum or minimum. So it gives us inconclusive. Therefore, to identify the point, the critical point is maximum or minimum, then only the first derivative test can be used to justify the answer. So go back to second derivative test here. If we getting our critical point and we notice that we substitute here second derivative, we get 0. So actually from the definition of f prime x equals to 0, the c that we found out here, it might be an inflection point. So it just might be or maybe an inflection point. So to identify whether it is inflection point, we have to undergo our test. So the test of inflection point, it can be using first derivative. We can notice the gradient of the tangent going down and going down, or going up or going up. So if you're using concave deviation test, second derivative test, we have to use table to identify that the interval before. So let's say this is your value as x equals to c. So we have to identify before c less than c, and this is more than c. We have to identify this curve is concave upward or concave downward. So if they have a concavity change, means the specific point here, it will be our inflection point. So the concavity might be changed from downward to upward, or it might be changed from upward to downward. So this is the use of second derivative test. So both tests, whether second derivative test or first derivative test, they are used to test your critical point, whether it's maximum or minimum or inflection point. So of course, inflection point will be start from f double prime equals to 0. So it might be also getting from your critical point, where you do your critical point, you substitute, you can't get it maximum, minimum. So your critical point there, it might be an inflection point. So we have to do our test to identify that critical point that you get is maximum or minimum or inflection. Or in other words, inflection point also happen when f double prime equals to 0.